this foundational proof carrying code. Let me show you the trusted base then. I'll blow up those two little circles to big. And we have, this is the axioms. Well, one of the axioms is, here's the opcode syntax of Spark machine instructions. Right? And this axiom is, here are the opcode semantics of Spark machine instructions. And then here are the axioms of arithmetic and higher order logic. And on the other hand, here's our proof checker. It's a C program. It's got to be a C program because we don't want to trust a garbage collector and a library. And you can actually write C without any runtime system, without any libraries, and what you see is what you get.
And get it right the first time. Trust the C.
Well, no, I'm not saying that there are no bugs. I'm saying the part of our system that you would have to get right is a total of 3,000 lines of code.
Plus all of GCC. Plus GCC.
Because you can do GCC-S, and you get 5,000 lines of assembly language, and it takes you about a day to read the assembly language and the source code to see that it was correctly translated this one time. So you kick GCC out of the trusted base. All right.
That's the assembly.
So then, to scale, then here's our trusted base compared with these other systems for the JIT compiler aspect of a system. Oh, but the caveat is it's not Java, it's ML, and it's not full scale. You know, it's not real in some sense. But this is the kind of thing you could try and get and make it real. I should remark that for all of this to really work, it's a good idea to write the JIT in a type-safe language. Because although you're going to check the output of the JIT, if the JIT is written in C or C++, then it could have bugs that itself crap out data structures while you're running the JIT. Okay? Forget checking the output. And so, you know, Mono gets this right, and Jikes gets it right, but there are a lot of commercial JITs out there that are, you know, it's really better to write it in Java. As long as you have the advantage of this type-safe language that's not going to, that's by and large going to respect its interfaces, you should use it. All right, so that was about the JIT. I'll say a few words about libraries. All right, so suppose you do this stuff and you can't use the JIT as a source of vulnerabilities. The attacker will then look at the libraries. And so what do? You find a bug in the libraries that can compromise security and you exploit it. So one solution maybe is you write your libraries in the type-safe source language, so now all the libraries are going to respect their interfaces even if they have bugs. The point is you accept that the libraries will have bugs. But even if they have bugs, they will respect their interfaces. So this is an easy answer, but it's not the whole answer. First of all, it's not possible to write every library in the type-safe source language, in Java, whatever. And second of all, that doesn't completely guarantee security. So let's investigate why. So here's three kinds of library code you might have in your system. The first is written in a unsafe source language, like C or C++, and which tends to have also access to privileges and that decides which privileges to grant to the user program. And so example is the JNI code, you know, the stuff that's running in the Java native interface in a Java system. Then you have your Java code that decides which privileges to grant to the application. So it's going to respect its interfaces, but if there are bugs in it, it will hand out the wrong privileges. And so that's a source of vulnerabilities. And then finally, you've got your type-safe user libraries that don't decide which privileges to hand out and are not called by the code that does decide which privileges to hand out. And you could try and get most of swing or something in there, and your quicksort function, and all the other utilities that are basically user code, but happen to be provided to the user in the package with the VM. And in principle, you shouldn't have to worry about bugs in there as security vulnerabilities. But yeah, the users might complain if there are bugs in there because their programs will run. So here's some snapshots of actual JVMs that we measured 3 or 4 years ago to scale, showing how big are their JITs and their unsafe libraries and their safe libraries. I don't believe we include, you know, big GUI libraries in this anyway. And I wouldn't trust this picture too much, but it gives you some idea, you know, how big are the parts in which the bugs could be lurking that cause security vulnerabilities. And I've heard all sorts of numbers about the size of the JIT in the IBM commercial JVM. But anyway, it's big. And It's a C++ program. That's the old one. The new one is presumably going to be way better.
So
Still a C++.
in the bullet train picture, which is unsafe live, so are those the ones we tagged as unsafe, or are those the ones written in C? I think those are the ones we tagged as unsafe.
I think they're the ones, well, they're both the ones written in C and the ones written in Java would be unsafe if something.
They have to be, that has to be unsafe. Java is too big.
Okay. Your GC is in the trusted base, but I'm running out of time.
How did you define the libraries?
Well, libraries are code that you can call through classes that come with the VM.
Okay, that are part of the base class libraries.
Yeah, basically. And but this is.
For example, there's in the CLR there's like XML processing the code. So is that part of the? It's not.
Yeah, it really gets fuzzy how you
Yeah.
categorize things, and I don't want to claim, especially for the library parts of this, that this is very
accurate.
definitive. And so let me just move on because I'm almost out of time. But I'm almost out of slides too. So let me just. All right. And the next thing is the application programmer is going to screw up in ways that maybe compromise the security of his or her own applications. And so we can open a book on programming securely in Java. Let's say the McGraw and Felton book, and there's one place where they say, here are 12 rules of thumb for programming securely in Java. Don't depend on initialization because the semantics of Java initialization are so cruddy. And limit access by making things private in package scope, and make things final so they can't be overridden in inherited code. And don't depend on package scope because it doesn't actually work very well, or it certainly didn't back then when they wrote the book. And don't use inner classes because they're not really hidden at the VM level. And so on and so forth. Don't let serialization happen because that can compromise the data in your abstract data types. And don't store secrets in your code. That's a rule in any language. Okay, and they wrote this before reflection came along, but I would say beware of reflection. So here are all these rules. Now, some of these rules are reasonable, right? It's fine to say, limit access to your classes, methods, variables. This is encapsulation, and make things final. That's a good idea in any system that permits it. And don't store secrets in your code. These are general rules of thumb in programming robustly and securely. But these other rules are just quirks of Java. And you shouldn't need so many of these rules, right? These are just crocs. Okay. And it's a shame.
Procs for security, though.
Well, but
I mean, how will inner classes compromise security?
well,
They're a convenient programming abstraction, and they have no relevance to security.
right. The thing about inner classes is normally you assume that things that are labeled sort of as the private part of your encapsulated class are not going to be manipulatable by the user. But because of the hack used in implementing inner classes in Java, which is that they're really outer classes in disguise, there's not as much security as you think there. So it's not necessarily true that you have to avoid inner classes, but there are certain things about them that you can't rely on them in a way that seems obvious from the source language. Okay, so the moral is that if the language designer were cleaner, you wouldn't need so many of the crocky rules. And that the applications programmers, these are really things that the applications programmer should think twice about using, unless they're really necessary. Yeah.
Just very briefly, I think part of the problem is there's a tension between actually getting stuff done and getting it done
Oh, I
securely.
agree. And I think that for some of these things, the introspection especially, the serialization and the
Right.
reflection, that you should make a distinction between certain middleware layers that are managing the top-level apps
Yeah.
that get to do these things
Yep.
and that are more trusted,
Yep.
and the top-level apps that are less trusted and shouldn't be allowed to use some of these things. And that would be a policy decision that you could make in constructing your layers. So conclusions. It's a good idea to write the JIT in a type-safe language. It's a good idea to have well-designed, sound type systems at various intermediate levels of your JIT compiler, and that will help kick parts of the JIT from the top down out of your trusted base. And if you want to get there with your existing JIT, you can get there one layer at a time. If you have a JIT where all the layers are untrusted in some sense, or need to be trusted because they can't be checked, you can put in a typed intermediate language here, right, so that you can produce it, check it, and then this phase of your compiler is, no longer in the trusted base, and then you can do it to the next layer down, and in a couple of years, you'll get there. And then our advertisement is that then at the very lowest level, you have this type system, and you want to really be sure that it's sound, right? The programming language theorem proving leaning community might be able to help you with that when you get there. Okay. And then there's some things I said about libraries, which I'm out of time, and about the application program.
Okay, so eventually I will tackle you when you're out on
Right.
stage, which is part of my job. So we'll take a few questions while Evelyn gets ready. So if anyone have any questions that they haven't already asked during the talk? No? Oh, he's got him. Let him get off that. Did you guys notice the slide where the code he wrote, the big, lots of white, very little purple? He had the most untrusted code. Did you notice that? So that's kind of